Thank you. Welcome. I'd like to offer the microphone to Gwen Leiter, our host for today.
Thank you, Dan, and thank you to all of our attendees. We are in for a very big treat today. We have giants from the VTOL world speaking today to all of you on design strategy and on the rules. And we are so pleased to be able to welcome Dan and Jason and Andy and Luigi and Marc and Glen to join us today and impart their wisdom to all of our GoAERO teams. Thank you all so very much for joining us. And gentlemen, I look forward to seeing you in Montreal quite soon. Appreciate all of your efforts and your expertise. Dan, turning it over to you for the introductions.
Thank you, Gwen. So today we'll spend just about an hour sharing several experts' view of the rules, giving the benefit of their thoughts. I'll do the introductions, and then we're going to go through the missions as an informal panel session and open it up to questions from the audience. Welcome to this webinar. My name is Dan Newman. I'm the CTO for Advanced Air Mobility for Honeywell. Again, as I said, we'll do an informal conversation among some vertical flight engineers of different tenure and different perspectives. I'd like to introduce them. To my left, to your right, starts with Jason Cornelius, a recent PhD from Penn State and currently the Vertical Flight Society chair for the Design Build Vertical Fly competition. Next to Jason is Marc Sheffler, former Boeing Director of Technology Integration. Then Luigi Ricci Moretti. He's currently the Vertical Flight Society chair for the Student Design Competition and an experienced vertical flight aircraft chief engineer who's worked on many advanced designs. Next is Andy Keith. He's at Sikorsky. He's formerly a VFS technical director. He's currently chief of propulsion engineering and formerly chief of preliminary design. And our last panelist, Glen Whitehouse. He's currently the Vertical Flight Society journal editor-in-chief, and he's the CEO of Continuum Dynamics. So our goal here is to spend a few minutes going through the currently published rules. And I've had some background on the rules and was part of the development. I'm fortunate to do that. But today I won't be commenting. We'll ask these five who, like you, have been exposed only to what the rules are, not why they are, nor the sausage making that got them developed, and ask their thoughts. We'll go through each of the three missions, and then we'll talk about the top level prizes and maybe some overall perspectives. I hope you find it interesting. So with that, we'll go to some charts. I don't want to spend too much on it, but as you recognize, GoAERO is a 3-year prize. It's a competition. It's a little bit different than a challenge. Make sure I don't want to read too much, but our goal here is to inspire creative designs that will generate sufficient points to earn the prize money. Just a reminder, this is an example of first responders trailer to move this system. This system is envisioned as a piece of kit, a tool that first responders can use, and the CONOP is not to be launched from their home base, but for them to take it with them. So that drives what the mission capability needs to be. Next chart, please. This is the motivation. I don't think there's a whole lot that needs to be said. Gwen and others have done some good publicity. Next chart, please. 3 stages. The first is a paper design. The second is a design where you demonstrate that you have working hardware at a minimum, a 33% subscale model. And then stage 3 will be a fly-off with as many teams as earn the right to get there. It's all clear in the rules. We'll not be talking about the staging. We'll be talking about the specific mission rules. Next chart, please. Here's the motivation. Whether this platform is to retrieve someone injured, or it is to retrieve a first responder who's at threat, such as a firefighter who gets trapped, or it's to deliver a first responder, whether a firefighter, police, EMS, medical. Our payload is essentially one human. not enough kit to be a full mission capability, but illustrative. And the goal is to get the smallest possible demonstration system for this competition that we felt was representative. So as you're aware, having read through the rules, and we'll make the assumption here that you've read through the rules at least once, essentially it's a triathlon. There's 3 events. There's a productivity event, an adversity event, and a maneuvering event. And then there are prizing for the individual missions and then overall. What we'll do today is we'll spend a few minutes on each of the missions individually, as if they were the only objective, and we'll get our panelists' views. And then we'll talk about the top prize, which is an aggregate of the performance in each of the 3 prizes. And to be clear, there may be a perfect answer, but it's unlikely. More like the real world, where we have a set of competing requirements, and there are many possible ways to do this. And we have attempted to set up a competition that demonstrates those capabilities. There are some things that we couldn't test. An open fire, smoke. There are some other things that can't be part of the competition. We've tried to insert as many capabilities as we can that would benefit first responders. And I think on the line today, Sky, would you do a comm check? Are you on the line?
I am here.
Good. Sky Sartorius is the primary author of the prize. He can answer questions for us and he can clarify. We'll attempt not to go into the reasons why today in order not to spend the time. We're going to focus on what the rules are. Recognize the rules may get clarified over time, but for now, these are the rules that we'll go with. Next chart, please, Dean. So this is Alex. This is a 125-pound mannequin. This will be an uncrewed competition. There will be no one on board, no person on board, just Alex. And again, Alex is representative. And our goal here is to demonstrate a capability to do these, to perform these tasks with Alex on board as specified in the rules. Next chart, please. And Alex will probably be dressed. So we'll move to the first mission, productivity mission. Ostensibly, it is what most transportation systems are to do, to move loads over a distance. It is a long time that will demonstrate the need for capability, significant amount of energy use, significant amount of wear and tear on the system, and robustness required. And with that, I think I'll turn it over and ask, let's start, Glen. Thoughts in particular on the productivity mission. What kind of features would be emphasized in order to achieve well in the productivity mission?
I think probably, high speed would help with the productivity. You do lots of cycles pretty quickly. Efficiency, energy efficiency would help as well.
Andy?
Yeah, so I agree. So the metric is payload over gross weight. So the less gross weight you have, the better, which is where efficiency would be most valuable. I would picture a big rotor or something like that to get the most lift for the least gross weight. But Glenn is right, the speed's going to matter as well. So if you can do 5 cycles instead of 3 cycles, you'll get a lot more payload.
And you're a propulsion expert. So what do you want to talk about power plant?
Yeah, so power plant wise, again, it's about efficiency. How efficient can you make the air vehicle? How many rotors do you want? Is one rotor is most efficient for hovering? Maybe 2 is better for cruise. Maybe 16's too many, right? So you really need to think about, I think it's all about minimizing the empty weight as much as practical to maximize the payload weight. And you want just enough power to do the 90 minutes, right? You don't want a lot of spare power as well because you're carrying excess around.
Okay, so I'll ask Luigi, with your experience on Project Zero, differentiate between power and energy, right? Andy talked about having enough power, but you also need the energy.
Definitely, and I think that the choice of the right kind of batteries or the right kind of propulsion system that delivers that power over the complete flight period and shaving the peaks for takeoff and landing and trying to average it as power supply and optimizing the energy delivery from the energy storage system should be something that should be looked in. I would like to offer also an additional comment regarding the payload installation or payload attachment to the aircraft. There are 3 different options. You can carry the mannequin, you can carry the rebar rods, or you can carry the sandbags. I think that the teams should be very careful in figuring out an intelligent and practical way of performing the loading and unloading, because you have to do at least 9 cycles of that. And you have to make sure that the stuff stays in the aircraft and doesn't get dropped off in flight. So I wouldn't disregard that part, which might be trivial from an aerospace point of view, but operationally is going to be crucial to bring home the points. So that will be my suggestion.
Right, so Mark, they've talked about batteries. Is that the only way to go? What are your thoughts on anything else?
No, I don't think that's necessary if you're looking at just this mission, as opposed to the other ones. And, you know, again, you could have a heavier vehicle that could carry a lot more of the weight and minimize the number of times that you have to make the cycle to reach the minimum weight required to score.
So I've heard about what the power plant is, what the configuration is, and Mark talks about actually the sizing mission, whether you size it just for one of those loads and do many, as Luigi said, 9 of them, or as Mark said, maybe bigger aircraft do less. Those are the choices available. Jason, thoughts?
Sure. So I'll share a little bit of a unique perspective, but a little bit in agreement with what Luigi pointed out, actually. For the competition that I run, the Vertical Flight Society's Design Build Vertical Flight Competition, one of the toughest aspects that the teams probably don't really anticipate ahead of time are the operation side of things. So not only how well their performance of the aircraft is going to be, but actually when we give them access to the flight line, they're on the clock. And so when we say, okay, you're up, they have to get out on the flight line, turn on the aircraft, get everything hooked up, get their ground control station and their autopilot and everything like this set up. And that's usually what takes the longest amount of time. So in this first part of the course and part of the mission, I think maybe the swapping of payload, physically getting the aircraft onto the field and getting it operational is going to be a challenge that the teams probably aren't too concerned about yet. And I think that's maybe where the emphasis should be.
Right, so inserted into the mission is that transportation with points available for doing better and clearly penalties for taking too long because it comes out of your productivity time. So good point. So we've talked about the payloads in several ways. We've talked about the transportation. Thank you. Good comments. We're going to move on now to the next mission. So the second mission is adversity. And while we've modeled this in terms of what we think it'll look like, we haven't offered that. We've only shared what the different landing sites are with a requirement to loiter in each of the landing sites, either airborne loiter or ground loiter. And the base is where we start. We have dry sand, a hill, which could be very interesting, a water-based with a challenge associated with it, the tornado, which will represent turbulence, and then an unknown, which will have some sort of on-the-fly, real-time decision how to approach that landing, which could be manual, which could be automated. This is an interesting one. It represents a lot of different possible scenarios. Let's start at this end. Jason, any thoughts and comments on it?
Yeah, I mean, it'll be an interesting one to tackle. Some of the objectives here are a little bit competing, right? On one aspect of the mission, you might try to go for something with a really high disk loading. But then, of course, if you try to land in a loose, dry sand pit, you're going to get some brownout and obscure the pilot's view to be able to fly the aircraft or anything like that. So each of them is a little bit different, and then as well the tornado. And so you have to try to think how you might design an aircraft that could handle all of these different environments adequately enough when maybe not exactly optimizing to just one of them. So it'll be an interesting problem to see how the teams work that out.
Yeah, Mark adds.
Yeah, a couple of things. First of all, you know, with some of the things not completely defined, like the tornado, you know, designing for your stability, you have to make certain assumptions about, you know, how much you want to design for, because it could be 40 knots, it could be 80 knots, 120 knots, who knows? Also, you know, when you're actually flying the course, because you're having to design for possible, you know, sand ingestion, water ingestion, so on, you know, you might even be considering what order you want to fly in to maximize the quote easier ones for your configuration first and save the harder ones for later.
Yep, good point. It was pointed out to me this morning that we're not actually addressing some of the more challenging for firefighting, which is the acidic environment that tends to get into seals and things. recognize that's something we couldn't necessarily test for, but it is one of the bigger challenges for designing a firefighting aircraft system. Luigi, any additions?
I would suggest a couple of points. Look at the different operation zones and landing requirements, and consider two aspects: the power required to cope with those conditions and the specific type of landing gear, and see whether choosing a different sequence of tackling the landing zones and maybe having a reconfigurable aircraft. And I don't want to get into details, but you certainly can imagine what could possibly that be. Choosing the sequence and the reconfiguration might be something that goes in line with, assuming you have a battery-powered aircraft, you're dropping battery performance as the batteries wear out. So think about that and try to tailor your mission profile and your target selection against your available energy or available power profile, for example.
So I'll just drop in that one of the tools of a configurator is adaptation that allows you to solve problems in series instead of at the same time. So instead of a compromise, you can, like retracting landing gear or putting flaps down, you can solve different problems at different times. And Luigi points out that you have the option of choosing which order to do these in, and therefore you actually set the sequence on the series. And if you have different configurations for different landing zones, maybe configuration, formulation A of the aircraft is for the hill and the pit and the tornado, and then the flood and the unknown are a different configuration. So
Very much.
these are the tools of the configurator. Andy, anything to add?
So I agree with all that. I like the idea of optimizing the order of success. My main thought on this mission is to me, it's pass-fail. You don't get extra points for doing it faster or slower or carrying more payload or any of that, like the other two missions. So I think you design your aircraft for the productivity and the maneuvering mission, and then you make sure it can pass this mission, right? With maybe picking the right order, maybe optimizing the landing gear and tweaking it as you go. But I don't see this as a driving requirement for the configuration. We'll see if that's true or not. That's my first look.
Glenn?
I think what sticks out to me of this mission is we need to think, or applicants need to think about fault tolerance and redundancy in their systems here. Because if you're relying on vision for landing or positioning, that's going to go out the window once you start picking up a cloud of dust. So you need to have some other way of knowing where you are, knowing what your altitude is, where you are relative to obstacles that you might not need for the other missions.
Excellent. Thank you. Okay, with that, we'll move on. So mission number 3, maneuvering mission. Now, just want to point out, they may not be done in that order. The layout of the competition venue has not been done yet, nor is the number of teams known. And so while they're listed missions 1, 2, and 3, they may not be performed in that order. Just a caveat. Maneuvering mission. This is to represent debris, trees, forests, really the value of vertical flight aircraft, the value of hovering aircraft, where there may not be a clear path, but there is an opening. We'll start at the other end and talk about this again. This is a timed mission. And Glenn, your thoughts as a
I think the thing that leapt out at me about this mission was more what wasn't defined. Usually when we think about a person carrying vehicle, there are constraints on the orientation that the vehicle can operate in, the accelerations the vehicle can do, because you don't want to hurt the passenger. That's not defined here. So the fact that there may well be no constraints on the accelerations that you can, your aircraft can do, that makes this wide open. You can start doing maneuvers you wouldn't normally envision doing in a conventional design.
Andy?
Yeah, this one's interesting because I think it's about agility. So it's about minimizing the time it takes to do the mission, which is really go as fast as you can on the straightaways and turn as quickly as possible on the turns. So it's like a Grand Prix, right? So you want to lay out the way you maneuver the mission, and you need a rotor and control system that's agile, that can provide high power maneuvering.
Thank you.
Right.
Luigi?
I will offer 2 points. The final gate gives you a maximum dimension constraint for the aircraft, and I think that that should be something that should be taken account right at the beginning for the also with respect to the rest of the missions. So this should be something that is upfront in the design for everyone. The other thing I concur with Andy, the maneuvering, I think there is a great latitude also in the choice of the profile. So don't try to fly the tightest course, try to fly the fastest course, and that might be different. Reed Schneider turns are different than tight turns.
Okay,
Trade energy for speed.
good point. Mark?
I think this is one where you might consider whether you can afford to put on some kind of additional aids in visualization and navigation in order to make these turns efficient. So that's something that I realize there's part of it where you may lose contact because of shielding or whatever, but for the most part, you know, some additional navigation aids may aid in performing the mission efficiently.
Okay. Jason, any additional thoughts?
Sure. Yeah, I think it's interesting that the 2 mission objectives here for the first mission and the third mission are quite contrary to each other. And so you might design an aircraft for the first one, which is that endurance course, maybe like a tilt rotor or a converting, tail sitter aircraft that can go long ranges very efficiently. But then you have this agility course. And so you have this trade-off between agility or maneuverability and stability. And so which of those 2 do you design your aircraft for? It's a really hard problem to answer in the beginning. You can't easily make an aircraft that does both of those very well. And so I think teams are going to have to take a very close look at the rules and ask themselves, do they want to try and strategize to be better at one of the courses than the other one?
And I want to invite Sky. Any comments here that you'd like to add based on what you've heard?
No, just I just wanted to make sure that it was clear that all of the missions are ranked. So it was mentioned that in the mission number 2 that things were pass fail. That one is also like the Newman mission, ranked by who was able to do it fastest.
Okay, right. So time is important in missions 2 and 3. And there's also this trade that strikes me as a mentor once said, the best way to go fast is to go slow. So we've got the tortoise and the hare with the recognition that the fastest adds risk. And every one of these participants has the opportunity to trade optimized versus a little bit of margin to reduce risk. Okay, that's good. Thank you. So next, having done the 3 missions, before we get to the questions, we're going to go to the next chart. There's an overall top prize, and the top prize is based on a combination. So here's the summary. Before we do that, the productivity, as Sky said, so productivity is to quickly deploy, and it's amortized by the total weight. So it's the total weight divided by the gross weight of the system. So that's a ratio and ranking. Adversity is time-based, and maneuvering is time-based. So different metrics, different capabilities. Next chart, please. So once you've thought about each of the 3 missions, we've got a top prize, the largest amount of money, and it's based on qualifying, which requires 25 points, 15 points for winning a mission, 10 points for 15 points for completing a mission, 10 points for partially completing a mission.
25. 25 for complete, 10
I'm
for
sorry.
partial.
30 required to qualify, and then added to those completion points are ranking points, and then there's bonus points. And just for a second, we're going to go to the next chart, and then I'll come back to this one. But as you think about these bonus points, there's also penalty points. And keep those in mind because they'll pull back away from the total. So if you go back one chart, and we'll dwell on this just for a minute. The top prize points. So this is the aircraft that overall performs best in terms of the points. It may not be the ideal representation of how to find a balanced design, but it's the one GoAERO has chosen, so it's good for today. I'm going to start in the middle. We've always started on the end, start in the middle with Luigi to talk about this challenge after having optimized for one and then optimized for another and optimized for a third. We don't get that luxury. Competitors get one aircraft and that aircraft can't change. The primary lift components can't change between those missions. So talk a little bit about the compromises between the three missions.
So I will suggest that the teams look at what the minimum common denominator across the three missions is, and try to identify what are the critical characteristics that the aircraft will have to fulfill while meeting these three missions. And then look at what is needed to meet the goals of the individual missions as a delta with respect to that basic configuration. And then it's going to be up to them to decide whether that delta is implemented in the basic aircraft or is considered as a kit equipment that gets switched around. Because the rules are pretty clear on the fact that you have to keep the primary lift system, but they don't define the primary lift system for which mission. They define that you have to have the primary control system, but they don't define if it is a primary control system for every mission or one mission, and the other ones have augmentation of some sort. So I think that one of the very interesting aspects of modern aircraft design is that systems can be configured, can be expanded, can be modified according to requirements. And if you come from the helicopter world where basically the helicopter is capable of nothing until you put the equipment on it, it just is a wheelbarrow and then you fill it. Well, I think that the approach should usually be pretty practical if it's taken like that. You could get something. And the other suggestion is read the rules carefully, read the scoring numbers carefully, and be a little bit wise in how you design to meet your goals, because you are going against points. Here, it's a competition. It's not the actual market for a customer, and you want to win by getting the most points. So some cleverness is in order.
Okay, we'll go to Andy. I'll just point out that, remember, conceptually, the prize is supposed to drive us toward a system that can be transported. So we have to bring everything with it. So the rules are written to try and achieve that purpose, but they are working against the rules, not against the mission. Andy?
So I think if you're trying to win, you assume you have to complete every mission. So if you're not going to get the full 25 points 3 times, you're not going to win, right? So then it's assuming I can do that, how do I beat my competitors in other metrics? So you look at workload, 9 extra points possible, and you also look at highest rank. So what you want to do if you want to win the thing is win at least one of the missions, ideally 2 of them, be the highest ranked candidate or competitor, as well as complete all 3 missions. And that's probably the best way to win. And then as Luigi says, now you're doing the trade-off to really optimize that for whatever configuration you've chosen.
All right, I'm going to go to Glen next, but before I do that, I want to encourage questions. We don't have many questions online yet, and we're leaving time at the end for questions. So I encourage you, please put questions into the chat. Glen, your thoughts on the overall top prize?
Yeah, I think that going in there and trying to, you're probably not going to put together an aircraft that wins all 3 missions with one configuration. So going in there with something that can either, can ideally win at least one, and possibly, maybe reconfigure itself to be a high rank contender in one of the others is probably the way to go.
Good. Jason?
Sure. Yeah, I think I have 2 main points here. The first one is kind of in line with what Luigi has already alluded to, is that, and I got this advice from someone that ran a similar competition many, many years ago during my time at Penn State. The team that knows the rules the best is best positioned to win the competition. We followed that on the team that I was involved with, and we did, we were very successful with it. I think that's a key, right? If you design, and this isn't only in a competition, but even in an engineering company, if you design a product because you think that that's the cool solution as an engineer, you're really intrigued to do, go down this path. That's not necessarily what the customer base wants or what the rules and the mission and scoring of the competition require you to do. So I think the team that pays most attention to that will have a very significant advantage. And then the second aspect is that something complicated is not always better. So in the VFS design build vertical flight competition, you know, we had some very exotic aircraft this past year, and it was very neat to see them. I mean, exceptional talent of the universities that built those aircraft and successfully flew them. But, you know, one team actually said, all right, we're going to make a quadcopter. And that thing was one of the, you know, at completing the missions, it was one of the best aircraft we had on the flight line. So there's something to say for a little bit of simplicity to achieve what you're being asked to, and not getting distracted by creating something that's kind of out there.
Thank you. And Mark, your comments.
Yeah, I think from my view, the first mission is a big difference from the other two, and that the other two, you know, are on speed and agility versus the first one wholly on payload efficiency. And so, you know, I think as opposed to Andy's view that in order to get the top prize, you're going to have to get 25 points on each of them. I'd actually be surprised and pleasantly if somebody can really pull that off with all the constraints. But you know, and the second thought is just that, as was mentioned, within the rules, if you can do different change outs of whatever is allowed for configuration in order to meet the different missions, you might benefit from that.
Thanks, Mark. Luigi, you had a comment?
Yeah, couple other sideline pointers. This equipment is going to be transported in a trailer, and the rule says that you're going to come over rough terrain and bumps and whatever. Make sure you strap everything down properly, because you don't want to damage it as you bring it to the test point. And as Dan mentioned earlier on, you have to assemble it. So it wouldn't be a good recommendation to have dummies that people can train on to make sure that your assembly procedures and your complexity of connections and so on is competition proof, not lab proof. You will be out in the open, and the weather might not be collaborating in that situation. So just make sure you think about that to make it as simple as robust as possible. You have to remember that EMS operators or first responders have other priorities in their mind rather than being accurate lab technicians dealing with electronics.
And while it's an uncrewed aircraft, uninhabited aircraft, safety of all humans involved is paramount. And that includes transport, that includes the procedures for assembly, repair, disassembly, any pressure bottles, any batteries, any voltages, and so on. Andy, additional comment?
Yeah, my other thought is just think about your timeline. So if you know the date of the competition, make sure you design your aircraft early enough, because usually you do a design, build, fly, fix, fly, fix, fly, fix, fly, right? And then as Luigi says, you can also practice your assembly technique. You can put it in a trailer and drive it around and see what breaks and figure out what you have to strap down better. So make sure you build in enough time so you don't have the design built, the aircraft built the day before the competition, because you'll probably have challenges then.
And build 3, because you'll crash one in test. You'll have one as a spare for your competition because you'll crash one in competition, and you want to have something left for the prize pictures.
So those are important pieces of winning, as well as having the perfect design as well.
And think through repair. What parts do you need? How do you get them on and off? How do you have enough? Okay, Mark?
I just want to add that, you know, as another trade-off, you know, we talk about maybe making things modular. The more complex the system, also remember, to get to the fly-off, you have to be airworthiness qualified. And so, you know, the more complex it is, the harder it's going to be to get the agencies to accept that. Something to consider.
Thank you. Glenn?
Yeah, so one thing I was thinking about it is factoring a robustness through the design process, not just for, hey, can I build something that will survive the trip to the site, and is it easy to assemble, but also an operational robustness that, you know, can you possibly come up with a design that is robust enough that maybe it can hit one of the pylons or the obstacles and not get destroyed and complete the mission. It may not be the optimal from a performance standpoint, but that robustness may give you the edge.
Yeah. Excellent. Jason?
Yeah, I do have one kind of additional comment in line with what's just been said on this part. So I know a minute ago I was saying don't go too complex, but at the same time, innovation is a good thing. In the DBVF competition, we had a team 1 year ago who made a large portion of their aircraft out of 3D printed materials. And everyone at the competition kind of thought, wow, that's a really crazy idea. Doesn't seem like that great of an idea at first, but then they crashed. They went inside, they printed a new component, rebuilt the aircraft very efficiently. I mean, if you're doing carbon fiber or something, but if you're using 3D printed components and you can swap out, a landing gear or maybe a piece of the wing section or something like that, it gives you a lot more flexibility to have an incident during the competition and then get back in there and get back in the game pretty rapidly. So the innovation, I think, is a good idea. And yeah, just agreeing with what's been said on that one.
Excellent, excellent. So we'll come back. We'll give you a second, but I want to start with some questions. Nidhi?
Thanks so much, Dan. We've got several questions coming in, so please continue to use the Q&A function in order to post any questions you might have. So one of the early questions we had is, how early can we start the design process? Are the parameters to optimize still subject to major changes? Skye, perhaps you can start us off here.
So definitely start now putting pen to paper. Nothing, it is not anticipated that there will be any major changes that would turn a good idea into a bad one or vice versa in terms of configuring your system for the competition. So then the earlier you get started, the better.
If you started yesterday, you're 3 days late.
Yeah, so, but let me also say that the illustrations are not to scale. So you need to recognize that the final maneuver may look a little different. And the final productivity may look a little different, depend on the venue, depend on how we straighten it out, but the objectives and the strengths of the aircraft will stay the same. Those features that will be valuable and the relative balance between how a feature benefits one mission and might hurt another mission will not change.
And you want to expect the unexpected, and that's actually written in the rules, to expect the unexpected, because this is exactly what public good missions need to deal with on a day-to-day basis. And so the intent of the rule set is to give you enough information to prepare, knowing that that it won't be exactly as you might imagine it in your head when you show up, but be prepared to adapt to that.
I would like to add one thing. Don't forget your supply chain. None of the teams probably will have the leverage of large corporations to force the suppliers into delivering what they want, when they want, at the price they want. They will be compelled to build with what they can purchase within the time frame and the budget that they have. And so I think that your design should be very much aware of making sure that you build into your concept stuff that you can procure, test, integrate, and have available in quantity by the time you need it. So don't design in unobtainium. The lead time is just too long.
Yes, so if I fail a mission on Monday, can I try it again on Wednesday, or is it a one-shot only event?
It might be one shot only. Just reduce. It has to do with the number of participants and the schedule. So it is definitely it is hugely advantageous to be able to have the system robust and reliable enough to get the points on the first try.
Thank you.
So don't design, but I would suggest don't design to meet it the first time, but don't show up without spare parts, because if you do get the opportunity of a refly after a failure, you don't want to miss it because you can't fix the aircraft in the meantime.
Okay, so Andy, I think your question was, do you get a second try? Did we address that?
Yes.
We
yes.
addressed
Okay,
that.
good,
I
good.
did.
Okay, next question. So at least you can hear me.
All right, I'll repeat it.
Can you swap out battery during the productivity test during the 90 minutes?
Can you swap out the battery during the productivity test during the 90 minutes? Skye, please.
Yes, absolutely. You can not only recharge and refuel, you can also refill oil or repair or whatever may need be with the equipment that you brought with you. All of that equipment that you bring with you, including all your spares, does count against the denominator of your score. But anything you choose to use the time for is allowed in terms of
So
being
for
both
instance,
swapping payloads and a pit crew.
okay, great. So one could have, say, 2 batteries. I fly 20 minutes on the first battery, then I swap them. Maybe I recharge battery 1 while battery 2 is running the vehicle, and then I can alternate. Might be more weight efficient than having 6 batteries or something, which is again up to the teams and how fast they can charge and what kind of battery they bought.
And how big their generator is.
Right.
Because that goes in the way.
So they can't assume ground power availability?
No, just like one shouldn't assume that when fighting a forest fire.
Got it.
So we're wondering if you can, anyone would like to volunteer, speak to the similar work they may have done, how they handled sort of different situations and scenarios, so that the participants on the call can learn a little bit more about your own personal experiences and your own work.
I could tell you generically what I would have done, right? You'd look at this mission, you'd look at, say, 10, this would be conceptual design. You'd look at maybe 10 different concepts, right? A tilt rotor, a tilt wing, a helicopter, a X2, whatever it might be. And you at top level evaluate the parameters of each of those and try to decide which might be the most attractive 2 or 3. And then for those 2 or 3 concepts, you more detailed design them. And in an ideal world, you'd run them through these 3 missions, simulate what you think your score would be, and figure out which of those concepts is the optimum by doing that simulation and math. And that would all be on paper in a computer.
Anyone else? Personal experience with new aircraft development? Luigi,
I'm going to
Project
offer it.
Zero?
I'm going to offer it exactly. You primed for that. I'm going to offer a slightly different perspective of Project Zero and little. First of all, redundancy. Put one of anything you don't forget, but don't overdo, because you might end up, unless you have a consistently redundant design, putting 3 of one and 1 of everything else might just be a weight penalty. So choose wisely what you make redundant. Don't just go for 3 of everything or something like that. And the other thing is test at the highest integration level, because you don't have time. So you have all, we have always a tendency to build 1 million test rigs for all the different bits and pieces. And then when we put everything together, then we find out that we have the wrong integration concept and things don't work, and you have wasted a lot of time on the bits and pieces. Build the whole thing and try it, and the first thing that doesn't work is the one you didn't think out well enough. It might be a little more expensive money-wise, but it's going to buy you a lot of time. We went from a sketch to a flying aircraft in 6 months, and it was much bigger than this on Project Zero. And we didn't do it because we tested every component. We did because we picked what we could do, we bolted it all together, and we fired it up and crossed fingers, and we were lucky. Don't forget, luck is a big part of engineering.
I'm going to rephrase the question just slightly here, but it says, how does winning this competition make the vehicle ready for real-world marketability? So perhaps we can consider how can we, by winning this competition, make a vehicle ready for real-world marketability?
Please repeat it for me.
Okay, I'll repeat it just in case they can't hear online. I could try to fix it up. But the question was, how can we create a vehicle to make it appropriate for real-world marketability?
Anyone?
I think there's no question about it that this competition is more of a technology demonstration than something that you'll immediately turn into an aircraft that's going to sell a lot, because it's to address different missions as a whole, but in reality it's unlikely that all the different kinds of people that are going to need it for whether it's delivering humanitarian relief or fighting fires are probably going to want one that's more optimized for what their needs are, I suspect. So, because you know, in trying to do everything for everybody in this competition, for all the different missions, you are going to have to make some obvious compromises. So you should understand what compromises you've made and understand how to uncompromise them if you're turning it into a market segment.
Luigi?
I think that, Mark, you're absolutely right about this. I would contend, however, that if you win this competition, I think that the winning team has developed enough of an understanding of the complexities of this problem that they will be very well positioned to take this technology and productionize it. It won't necessarily be the same aircraft. It might meet a different design point, but they will have turned enough stones to get a reasonably good idea of what the challenges are. So try to win, but primarily try to learn what it takes to get you through this.
And then once you've learned that, you might want to scale it up because Alex is kind of light for a human, right?
Yeah.
And you might want to make it more robust. You might learn some things about how to make it more easier on the battlefield, quote, right, in the area. But I agree with you, Luigi. The winner will have a big leg up on being able to go to market with this kind of aircraft.
Yeah, maybe think of it as a technology demonstrator.
It very much is.
Yeah.
And it will build credibility.
Okay, so real quick, I'm just gonna ask Andy to clarify. I use the terms X-plane and Y-plane and prototype and minimal viable product. Some people don't quite have as many. Would you characterize where this is and how long it would, how many more it would take to get to a production one, just to calibrate people what they're actually gonna deliver versus a market?
I think this is further along than an X-plane. An X-plane's just proving that concept can work, essentially, right? I can fly supersonic and make no sonic boom or whatever it is. So this is way beyond that because this is doing various missions. You're doing the compromising already. So it's a Y plane or even a prototype. And then to me, you would productionize the prototype. You might tweak the design based on the scaling, but I think
So
you're a lot further along than an X-plane.
It's not a product, but it's a hell of a lot closer than most.
That'd be my
Okay,
take.
good. Jason?
I would like to push a little bit more on something that was said about credibility. I think that this market isn't too opened up yet. And so the aircraft that come out of this competition may be well suited for something like venture capital investment. And so we see that a lot now with urban air mobility, where these VC firms are investing a lot of money to try and get those concepts and those configurations into reality. Someone that wins this competition would have a serious chance to go into Silicon Valley's VC and say, hey, we won this really big competition, which has some prize money, but I mean, it opens the door up to getting millions and millions of dollars of investment to actually go and develop a product. Yeah.
Well, we have a lot of questions, so apologies. I'm going to keep us moving since we're kind of, heading at our time here. But I'm curious, do you all have thoughts on existing examples of working commercial aircrafts that might fit the competition, perhaps to offer some inspiration?
I'm embarrassed to say no. Because I mean, I tried very deliberately not to solutionize this thing and look at the thing in general terms, but there are definitely products around that we've seen in videos that could be adapted to this. But I don't want to name names because I don't mean to endorse or not endorse one or the other. I'm sure that the people who are participating in this thing are just as aware of what floats around on YouTube and TikTok as we all are, if not more. So.
Yeah, so I think some existing helicopters, just to pick on that, could do the productivity mission and the adversity mission. It's the maneuvering mission that has that size constraint Luigi mentioned, and the speed constraint. So that would the thing that makes it the hardest to take an off-the-shelf aircraft. But I think there are aircraft capable of these types of things, right? You scaled it down a little bit, but Whether it would win is another story, right?
Okay, maybe one last question.
What would you consider to be a competitive payload to gross weight ratio?
Well, what's a helicopter today?
So a big helicopter weight empty, which is not just payload, right? 55% if you're really, really good, right? 70 maybe payload would be 25% maybe.
But that presumes you've already gotten a certain amount of fuel on a certain mission. So
Yes.
empty weight is 55%, and the rest is payload and fuel.
Right. Now this could be better because it's unmanned. You have a lot more technology. So that would help.
I will contend if you get it to 25, payload 25%, 75%, rest of the aircraft, you're going to be good.
Remember that you're doing it quickly.
Competitive.
You're doing it quickly. You're not optimizing. You need margin. You want it robust. You can't do all the analysis.
So if
So
Alex,
all of that eats into your efficiency in order to make sure it doesn't break.
if Alex is 125 pounds and you want to do these missions, the all up weight should, my feeling is it's in 500 pound and counting, not less than that.
Right.
And
batteries
yeah,
are heavy.
including batteries.
Yeah.
You know, the
That's a
MTO,
short-
yeah,
it's a
the
short
MTOW,
mission.
I would say that it's
Yeah.
my eyeball will be for three more
Okay.
than the payload.
Good.
But
So
You'd
that's
start
just
at 500
hunch.
and aim for less.
Okay, we're going to try two more quick questions, but all of them can be submitted online and we will get to them. We will get them answered either by our panel or by others. Nidhi?
What are the preferred fuel logistics?
What are the preferred fuel logistics?
Are you using a battery or are you using a gas engine? That's the first question you want to think about.
We stated that we shouldn't be using exotic fuels that are dangerous, but nobody prevents using exotic fuels that are not dangerous. The problem goes back to your supply chain. Make sure you can buy the exotic fuels, because hypergolic propulsion for torpedo is an option, but I think that you can't just go to Home Depot and get a jerry can of that. And so that's something you should look into. Remember, there is no limitation on the MTOW at any single mission. So your aircraft might weigh different under different missions as maximum takeoff weight, because it could be configured differently. So think about that when you design the aircraft. Don't lock yourself into it.
Okay.
Yeah, and I may suggest that this competition might have teams kind of going in the direction of electric batteries, of course. And even within that, there are a lot of different options. So for DBVF, we've actually restricted the teams pretty heavily. And we said, this is the exact type of lithium polymer battery. Here's the maximum cell count you're allowed to use. We restrict how they're allowed to tie them together, all for safety precautions. But and also on the other hand, to keep teams kind of on a similar playing field. If this competition, if the rules don't explicitly say you have to use this type of battery, there are quite a lot of options. So teams may benefit from doing some initial research on what is out there beyond just the standard lithium polymer that could give them a competitive edge.
Okay, last question, Nidhi?
To what extent can parts of the aircraft remain on the aircraft but be deployable?
Can you ask the question again? Sorry.
Now, let's give that one to Sky. It's to what extent can parts remain on the aircraft and be deployable, which I would consider adaptation or reconfiguration, like landing gear retraction or deploying slats and flaps and so on. Sky, you want to touch?
I think you hit the nail on the head. The way that question is phrased, it exactly refers to things like retractable landing gear and reconfiguring the aircraft, whether it's things that fold or rotate or tilt. There's nothing in the rules that restricts that, and it may be warranted by given approach to a mission or to the competition.
Excellent. And with that, we're out of time. I thank the panel very much. Thank you all for joining. I hope it was interesting. I hope you learned something. I hope it inspired more questions that can be answered online. Thank you very much. Thank you all. Thanks for joining.